And here we have a couple important points about triangles. As we mentioned under lines and angles, the sum of all the interior angles of a triangle is 180 degrees. Perimeter, that's the easy one. We're just interested in what the length of each side is, and we'll add those together. And then the area, we can determine in different ways depending on the information that we're given. I think we're used to being given the base, often listed with the variable b and height h, and therefore we can calculate the area by finding base times height and dividing that by 2, or taking 1/2 and multiplying that by base times height. I recall that you can manipulate these formulas, any of the ones we're going to look at, in whatever way you need to. So this could also be expressed as base times height divided by 2, and that's just multiplying numerators and multiplying denominators. Or if we don't know what the height is, but we do know all three sides, we can use Hero's formula to find the area. For Hero's formula, A, B, and C are the three sides of the triangle. S is used throughout that formula. And what is S? Well, S is 1/2 times A plus B plus C. In other words, S is just 1/2 of the perimeter. And we'll see how that looks in action. All right, it simply asks us to find the area of these triangles. In this case, what information do we have? Well, for the left-hand triangle, we have the base. We know that the base is 16.2 centimeters, and we have the height. Turns out that the triangle on the right-hand side has the same base and has exactly the same height. So this is just a reminder that whether the height can be captured within the triangle as it can on the left, or whether we have to extrapolate so that we can draw in this height, either works to calculate the area. So these two triangles actually have the same area. The area we know is equal to 1/2 base times height. So I'll write the formula one more time and then fill it in. Base is given as 16.2 centimeters, and the height is 5.75, also centimeters. So 1/2 times 16.2 times 5.75 gives us 46.6 centimeters squared, and I've rounded that to the nearest tenth. How am I sure that it is centimeters squared? Well, the 1/2 is unitless. 16.2 is measured in centimeters. 5.75 is measured in centimeters, and centimeters times centimeters is centimeters squared, giving us our final answer of 46.6 centimeters squared. For this question, we're being asked to find both the perimeter and the area. And this is one of those situations where we're not given the height of the triangle. There's nothing we can do for this regular triangle that isn't equilateral or isosceles or a right angle triangle. All we can do is apply Hero's formula. So here's Hero's formula again. It tells us that the area is equal to the square root of this whole mess, S times S minus A times S minus B and S minus C, where A, B, and C are the three sides. So I'll label these. It doesn't matter which one is A, which one is B, and which one is C. However, what we do need to calculate before we can keep going here is the value of S. And S is 1/2 of the perimeter, or 1/2 the sum of the three sides. So that's 1/2 2.56 plus 3.22 plus 4.89. And that's all in meters. Meters plus meters plus meters is still meters. Divided by 2 or multiplied by 1/2, however you're calculating it, is 5.335 meters. I've already decided, and it's not indicated here, so I get to choose. I've already decided that I'm going to round my answer to 1 decimal place, so I've kept 2 additional decimal places in any intermediate step. So I want to make sure that I don't round intermediate steps. I want to save that for the final answer. All right, so this one's going to be a long one. Each S is 5.335. So we have 5.335 minus 2.56. So A, one of our sides. And then once again, 5.335 minus 4.89. And then finally, 5.335 minus 3.22, the last side. I should extend that radical so that it does encompass everything underneath. Now this is just number crunching, and in fact, if you're using brackets appropriately with your calculator, you can do this all in one go. If I was to enter this on my calculator, I would choose the square root symbol, open up a bracket, punch in 5.335, open bracket, 5.335 minus 2.56, close bracket, and so on. And then finally close the bracket to indicate that I've entered everything I need to under that radical sign, hit equals, and we get, rounded to 1 decimal place, 3.7. 3.7, what? Units are really important here, and it's 3.7 meters squared. It is a measure of area. How do we know for sure that we're in meters squared? Let's have a quick look at the units that are given. So S is always given in meters. So we have meters. Meters minus meters is still in meters. Meters minus meters, meters here. So meters times meters times meters times meters means we're trying to take the square root of meters to the power of 4. What times itself twice gives me m to the power of 4? Well, the answer to that is m2. So what this does, or what considering the units does for me, is it helps me to ensure that I have done the calculation correctly. If my units don't work out, I haven't done my calculation correctly either.